Here we have a rough sketch of a Maxwell-Boltzmann diagram. So we want to learn how to read these and what it actually looks like, what the axes are. Here we have the y-axis, which tells us how many particles there are. And then on the x-axis, we can do kinetic energy, we can do speed, but it's a distribution. So we need to understand what a distribution is. To do that, here's this little toy called a Galton board, and it's got these beads in it. And if you watch what happens, those beads fill up the distribution, that curve, almost like a bar graph. And that's exactly what we're looking at. We can see how many beads land at each position. So this x-axis is a position. And we get a lot of beads here and just a few on the sides. And it's because of a probability. For the beads to get over here, they would have to go right, left. And it's just more common to have them here gathered around the center of that distribution. So we get a large number in the middle and a few particles on the outside. We want to see that same thing in this chart. There are a lot of particles. So if we had 100 particles, we would see most of them here in the middle, traveling at this kinetic energy, and just a few of them on the outsides. Now what happens if we heat it up? Well, if we heat it up, those particles are all going to change. So what happens is we're going to get a new distribution. So let me remake that one. Now, some of the particles are always going to have a low energy. So I've taped this down to see if we heat it up, in order to have the same number of particles that I had before under here, but just heat it up with more energy, it would be like pulling this, and you see that the particles are slowly getting faster. Some of them are over here now, and they're moving faster, but the distribution is getting wider and the peaks are getting narrower. So now we've got fewer particles in the middle, but I've got a much wider middle, because now I have a fair number of particles going faster over here, and I still have a couple of them going really slow, because particles are going to have different kinetic energies. But the distribution is now wider. So the peak is lower and the graph is shifted towards a higher energy. The particles are going to be moving faster, but I still have the total same number of particles, because no matter how I shift that curve, if I have a closed system, no matter what, I have the same number of particles. They're just going to make slightly different graphs if I start moving things around. So the area under the curve has to be the exact same, but we just need to read this as a bar graph. And that's how you read a Maxwell-Boltzmann distribution.